All these three methods are used to find the solution, feasible solution, to minimize the transportation cost. See, suppose now there are service centers S1, S2, S3, S4, and so on, S7. These are the service centers. Then we can supply the goods from these service centers S1, S2, and so on, S7 with the capacity of A1. The capacity of the service center S1 is A1, okay, and capacity of service center S2 is A2, A3, A4, and so on, A, okay, A1, A2, A3, and so on, AM denotes the capacity of the service centers S1, S2, S3, and so on, S7. Now we have to supply these goods to the demand centers. Demand center means requirement. When the requirement is available, then we can transport these goods to the demand centers. See, for example, there are demand centers D1, D2, D3, and so on, Dn. These are the demand centers D1, D2, D3, and so on, with the capacity of B1, B2, B3, and so on, Bn. Okay, service centers. Okay, so now we have to supply the goods from these service centers A1, A2, A3, and so on, this to the demand centers D1, D2, D3. Let us say C11 with the transportation cost. C11 is the transportation cost to transport one unit from this service center to this demand center D1. C11 denotes the cost per unit. Cost per unit to transport one good from service center S1 to demand center D1. Similarly, C12 is the cost, C13, and so on, C1n you can take. Okay. Similarly, C21, C22, C23, and so on. These are all transportation costs. Okay. This C21 denotes the transportation cost to transport the goods from the service center C2 to the D1. This is C22 is the transportation cost to transport the service center S2 to the demand center D2. Likewise, you can write C31, C32, C33, and so on, C3n. Likewise, C41, C42, C43, C4n, CM1, CM2, CM3, and so on, CMn. Okay, these are the transportation costs. Now we have to allocate the cells. Allocate the cell means how many units are transporting from this service center to the demand center D1. So demand is V1. But how many units are transporting from S1 to D1 now? See, for example, suppose the demand is 4 units here. Demand is 4, okay, and capacity is 6. Okay, the capacity of the service center S1 is 6 units, for example, but the demand at the center D1 is 4. Okay, how can you allocate the cells? Okay, how can you allocate the cells means we can take the minimum of the demand is 4, but the requirement is 6. So how many units you can allocate? Maximum of 4 units only. Why? Because the minimum of 4,6 is 4. We can allocate 4 cells, but allocation is depends upon the methods which you are following. That means northwest corner method, east cost method, Bosel's cost method. That means which cell you have to allocate the first, then which cell you allocate next. That's important. Okay. That further we can use 3 methods: northwest corner, east cost method. Okay. So here X11 denotes the number of units. The number of units are transporting from S1 to D1. Okay. Similarly, X12 denotes the number of units are transporting from S1 to D2. C12 is the cost. X12 is the number of units. Okay. Similarly, we can write X13. Okay. X21, X22, X23, 2, 3, and so on x2n. Okay, x31, x32, x33, x41, x42, x43. So whenever you round off means that is allocation cell. Allocation cell. Non-allocated cell means we can give the cross mark. Cross mark means not allocated cell. Okay. So then how can you find the transportation cost means the minimize z equal to summation I is equal to 1 to m sigma j is equal to 1 to n Cij into Xij. This is the formula to find the minimization of cost. Minimize z means the minimum of transportation cost. Minimize z. So sigma I is equal to 1 to m, sigma j is equal to 1 to n, Cij Xij. That means we just multiply Cij into Xij plus C12 into X12, C13 into X13. Likewise, we can add all these allocated cells only. We can omit non-allocated cells. Okay, we can add only allocated cells. Okay, this is the transportation model. So to work out this transportation model, we have to follow some conditions. One of those conditions means the supply. This is the supply. This is the demand. Okay, supply must equal to demand. Supply must equal to demand. That means sigma I is equal to 1 to m Ai is equal to sigma j is equal to 1 to n Ba. Okay, the supply total of A1, A2, and so on. Demand B1 and so on. Bm. The supply must equal to demand. Okay, the number of allocations. The number of allocations must be equal to m plus n minus 1. The number of allocations must be equal to m plus n minus. What is m and what is n means? M is the number of rows and n is the number of columns. If we satisfy these two conditions, we can work out this problem. Okay, once if we get the solution, we can check the optimality also. Okay, and optimality means is there any solution better than the solution? The one solution may be obtained by using northwest corner method, least cost method, or Rosas approximation method, and then again we can check whether the solution is optimal or not. If it is not optimal, we can get the improved solution. Improved solution means again we can reduce the transportation cost by just interchanging the allocations of cells in the transportation model. Okay, so we'll start first northwest corner method.